Okay, so welcome to everyone on our 35th iOS Developers Meetup. This is our first letSwift of the year, and as you can see, we have some exciting changes. The first one is we have the new host. You can recognize Marcin from stealing all your prizes during our quizzes on the previous events. So welcome him with a big applause. And the other change is that we are changing our main language on the event because we are opening for the worldwide Swift community. We are going international, so we will try to speak English now. Yeah.
All right. Hello to everyone in the room and hello to everyone watching us on our YouTube channel on the live stream. So today we have two exciting talks from our speakers. So first of all, we got Sebastian Osiński, who will take us behind the scenes of Goodnotes' new toolbar. Last but not least, Tymoteusz Pasieka, which will talk about the native iOS in the world of game engines on an example of building a children app without using any pre-built game engine. So after every talk, we'll have a Q&A session, so feel free to ask any questions that are on your mind.
Yeah, perfect. So, and we have some exciting news because this year, we will mark the 10th anniversary of the letSwift event. The first one was hosted in 2016. So it is a big moment for us, and I would like to thank every one of the person that was building this event with us. Thank you, and we hope to see you in the next 10 years. Yeah, and the event couldn't... Yeah, thank you. The event couldn't be organized without our main partner and sponsor, which is Droids on Roids. And Droids on Roids is a software house specializing in mobile app development in Wrocław and operating in international market. It transfers ideas into I know this in Polish, but in English it's hard. Innovative and functional solutions for companies worldwide. Droids on Roids is part of Academy, a leading European digital product company trusted by brands such as Domino's, BBC, and NHS. Yeah.
So this time for our letSwift app of the event segment, we got a Smart Kiddo. So this is actually the app created by one of our speakers. So Smart Kiddo is an educational game for children age 3+ created by today's speaker Tymoteusz, together with his wife, who was working as a graphic designer for the app. And the app actually was featured by Apple in the App Store in 32 countries. It includes puzzles that develop logical thinking and simple educational assistant based on the Apple latest on-device language model, which I hope we'll learn more about today. The agent actually answers children's question in a safe and easy to understand way. So we really encourage you to give this app a chance. There is a QR code to download it from the App Store. And hopefully today you will hear more about the technology behind the product. In the talk of by Tymoteusz. And if you would like to showcase your app on our stage, we encourage you to actually submit your app using the QR code on the screen. So we are open for submissions. Scan the QR code, submit the form, and maybe we'll post it on our socials and feature it on the next event.
Yeah, and we have a lot of QR codes today. So all of the QR codes will be posted on our social media. So if you're interested, you can scan it now or later on our Twitter or Facebook. And we are open for new speakers to come here to talk about some exciting things about Swift-related topics. So if you want to participate in the letSwift, come here on this stage and show something you have built or you're interested in. You can fill the form, which is called Call for Papers, and you will be on our next meeting.
All right, now it's time for our first speaker, Sebastian Osiński. So a few words about Sebastian. Sebastian currently works at Goodnotes, where his primary focus is toolbar and document editing UX, and he has over 10 years of experience in iOS development. Yes, Sebastian actually fears public speaking, but somehow agrees to do it again and again. And don't be fooled by his appearance, because he's not gonna talk about accessibility today, which might be surpriseful. Yeah. Sebastian Osiński with behind the scenes of Goodnotes' new toolbar. Please welcome to the stage my good friend Sebastian. And Sebastian, the stage is yours.
I need your help. Just give it a second, it should be okay. It's not a proper presentation without some technical problems, so. Perfect. Great. So, as Martin said, I'm Sebastian. I work as an iOS developer at Goodnotes, and also as Martin mentioned, I fear public speaking, and somehow I agreed to do that again and again. This time I had a problem agreeing, so they made me comply. Is it working? Oh, no. Perfect. So once again about me, I'm Sebastian. I work at Goodnotes, where I primarily focus on toolbar and our document editing experience. And what even is Goodnotes? Goodnotes is a note-taking application. We are available on iPad, macOS, iPhones, web, Android, and Windows. But today we'll, of course, primarily focus on our Apple platforms. And last year we went through a big makeover. And one of the parts of this makeover was our toolbar. So our old toolbar was pretty battle tested. We used it for a long time. It was well known by our users. But over time it became crowded while we were adding new tools. It also became pretty tightly coupled underneath the UI and business logic. So the underlying views and view models started growing a lot, and keeping updating it, and making changes to it was harder and harder. Also, we wanted to introduce new document types in our new app version, where each document type can have slightly different toolbar or completely different toolbar. So we wanted to have a solution which would allow us to do that. So we went and completely redesigned the new toolbar. And we could have done just the redesign, but we also changed the implementation underneath completely. We wanted to have something which feels like building toolbars with Legos. If we want to change something, we just move the pieces around, and it just works. And we achieved that, at least in my opinion. We created a new toolbar which is built from independent pieces, which nicely coexist together, and I will show you in a second how it works. But first, let's see how the new toolbar even behaves in the app. Oh, sorry. So yeah, we have two levels of toolbars. The main toolbar, where we have our main tools, and we also have a floating toolbar, which, depending on the tool, contains additional options or additional subtools. The toolbar nicely adjusts to the screen sizes, both on macOS, iPadOS, and iPhone. On the video, you might have seen some slight glitches, but that's just a simulator recording. In the real app, it's really smooth. So let's go through the building blocks the toolbars built with. The first building block and the most important block is something we call toolbar element. Each piece of the toolbar circled in red is a separate toolbar element. So and they are completely independent. They can be rearranged. Removing any of those elements doesn't affect any other elements. So, for example, we can conditionally hide tools or options based on feature flags, any kind of configuration. Also, the toolbar itself doesn't know anything about business logic. Business logic is neatly hidden in each toolbar element and in some shared in some shared data sources. You can think of each toolbar element as a view model of this single piece of UI in a toolbar. So let's see how it looks like in a code. So toolbar element by itself is a simple protocol which defines how the element should look like with the user interface property. It's not a view, it's a descriptor, which I will explain a bit next. Each toolbar element can also have a floating toolbar associated with itself. So if it gets selected in the main toolbar, its floating toolbar will be presented. And also we can control things like its visibility and so on. So technically, toolbar element can exist in a toolbar, but for some reason might not be displayed at all. For example, because of feature flags or some other options. And one of the basic behaviors of a toolbar element is reacting to taps and long presses and other gestures. So each toolbar element has a callback in the form of an on-tap and on-long press function to get that information. And each toolbar element, if anything changes in that toolbar element, for example, if its selection state changes, its user interface changes, it notifies its delegate, which we'll see later what is delegate of the main toolbar, where does this go. So as I mentioned, we describe the UI in something called toolbar element UI descriptor. It's just a nested enum. It contains all the data in associated values required to render this specific toolbar element. We at first considered allowing toolbar elements defining views or their views in form of either UI views or Swift UI views. But if we wanted to use Swift UI views, we would need to wrap them in any views and anonymize them. And that would influence Swift UI layouting, animations, because we would lose the identity of views. And the UI views, we didn't want to use UI views because we wanted to have the internal implementation to be in a Swift UI. So we decided on this approach where all those cases underneath are mapped to appropriate Swift UI views, and Swift UI does its magic, diffs the data and updates only the places which are required to be updated. And let's now, not sure if you can see the code clearly. Is it visible? Okay, so this is a example of an implementation of a toolbar element. It's, as I said, a simple class which just reacts to changes in a global state. And if the state changes, it updates its value. So if selected changes, that will trigger next update to the UI. Same with the user interface. So if any of pen options change, they might affect how the UI looks like. And if the element gets tapped, it either presents a popover with options, or it selects a tool. And this is how it looks like in in action. So if we change any option, this element's UI changes automatically just by updating that user interface property or its selection state. The next building block is something we call toolbar element section. It's just a group of elements allowing us to bundle them together. It influences the layout a bit and also allow us to address some sizing issues which we'll go later more in depth into. And its implementation is as simple as I can imagine. It's just a simple struct with the array of elements, ID, and a couple other properties which I will show later. And as I mentioned earlier, if an element is in a main toolbar, it can have a floating toolbar associated with itself. So if this element gets selected, its floating toolbar will be presented automatically. So here you can see if we change a selected tool to a eraser, a new floating toolbar is presented. And floating toolbar can also be thought as a view model. It's basically a view model of view models. So again, it's a simple protocol. Oh, sorry. Yes, simple protocol with just a bunch of children of sections, which underneath are toolbar elements. And if anything changes, that affects the UI. So all the business logic is hidden in the implementations of floating toolbars, implementations of toolbar elements. And we can test them, unit test them without touching the UI, touching the rendering or anything like that. And you can see it in action here, where we have our writing tools toolbar. And once I play the video, we select one of those other tools. This part of the toolbar will change because it's updated its children. And all of that logic, the toolbar infrastructure doesn't know anything about that. It doesn't have to handle those cases in any way. All that behavior is implemented in this specific floating toolbar implementation. So we can freely change it. We can have different behaviors between different floating toolbars. And let's see how how the infrastructure of the toolbar looks like. So this is our infrastructure. I already talked about toolbar element descriptor, toolbar element protocol, floating toolbar. And we have something called toolbar configuration provider, which provides the first list of elements to be displayed in this main toolbar, the blue toolbar. This gets fed, those specific elements get fed to main toolbar view model, which only responsibility is to display those main toolbar elements. The main toolbar view model is the delegate of those toolbar elements, so if anything changes, main toolbar view model handles the updates and triggers the updates to the UI. It also handles screen size changes based on some rules I will show later. Then, of course, main toolbar view model displays that in the main toolbar view controller. And if a toolbar element has a floating toolbar associated with itself, that concrete floating toolbar implementation has its own floating toolbar element, and those are displayed in a floating toolbar view model. And both of those view controllers are inside something we call toolbar coordinator view controller. its responsibility is to display the main toolbar, so the blue, to host the main toolbar and display it in the view hierarchy in the app, coordinate the presentation of floating toolbars. So if current floating toolbar or current selected element changes, the toolbar coordinator of the controller handles that. And it also controls dragging of the toolbar. On the video in the beginning, I showed you that we could drag the toolbar to the different places on the screen. And that actually is handled by our internal library for floating UI elements, as our floating toolbars are not the only floating elements which we now display over the canvas. There is a couple more, and we need to handle collisions between them. So this is offloaded to a separate library, and it's basically a implementation detail which this setup doesn't concern itself about too much. So when we were developing this, we started work on the new toolbar around February or March last year, aiming for release around September. However, we first released to say minor public in form of a big beta around June, and during that pretty short time, we had a couple challenges to address. So the first one, and probably the hardest one, was sizing. As you've seen on the on the video in the beginning, we need to adjust the toolbar and its contents to various screen sizes. Not only different iPad versions, iPad screen sizes, but also iPhone. On macOS, you can freely change the screen size, and starting with iPadOS 26, you can also freely change iPad window, app window screen sizes. So we have to support them all. And our approach is twofold right now. There is a different approach for the main toolbar, the blue one, and the floating toolbar. So let's go through those one by one. The first one is main toolbar. With the main toolbar, we decided to have a much more dynamic approach, so each toolbar element can decide if it should be visible in a given screen size. If, for example, screen size, viewport size is not enough, the toolbar element itself can just say, you know what, I'm not that important, just don't display me, there is no need. On top of that, toolbar element section define how overflow behaviors should work like. So if there is not enough space, that section can either start scrolling, so the elements will, the section will be shorter, but will allow scrolling inside, or the elements will start disappearing from the section, and a overflow menu will appear. So a popover where the elements are displayed in rows, and user can select it from them. Or the section can just say, you know what, I need to display all of my elements always. Let the other sections decide how to do it. And we can freely adjust how it works. The main toolbar view model handled that, makes basically no assumptions about the layout. So we can pretty dynamically change that without diving deep into the layout code. Of course, it's possible to configure it that way that something will start breaking, like if we put 20 toolbar elements in the main toolbar, and we won't tell it that it should start scrolling or showing in an overflow menu. It might start breaking, but we don't do that. We don't do that. Also, in the actual implementation, because this is a bit simplified, all of those options, all of those cases have some additional sub-options to influence the behavior a bit more. And for the floating toolbars, we went with a different approach. We decided to not make them fully dynamic, but have a couple predefined sizes. Right now, we have 3 main sizes, small, medium, large, and special size we call docked if the screen's really small, like on iPhone or on iPad with the viewport changed to minimum. We use this docked size, which basically moves the floating toolbar a bit up, and it appears not floating anymore. And also our undo, redo buttons disappear, and they are presented in the toolbar itself. And the way it works is that each toolbar element in the floating toolbar defines in what sizes it should be displayed in a form of a mask. So we can combine them freely. So element can define that I should be displayed only in the large size, or I should be displayed in the small and large size, or all of them, and so on. And if our designers decide that some element should, this should change, the change in the code base is just changing the value of this property in this one element, and it just works. Another problem we encountered was around rendering. So as I mentioned, first we wanted to have independent pieces in a toolbar, so each toolbar element is fully independent. However, this introduces some problems. You can imagine that if you have toolbar elements which represent selected tool, once you change a tool, 2 toolbar elements update. One needs to get deselected, the second one needs to get selected. So at first, we just implemented in such a way that if anything on the toolbar element changed, that would go straight to the view model, and it would update, it would trigger SwiftUI update. So changing a tool basically cost 2 updates to SwiftUI views, because in the same frame. And that actually started causing problems when we tried animations, and SwiftUI started glitching. So what we came up with is a more indirect approach. In the main toolbar view model, when any element updates, it just marks the UI as dirty. So it marks the UI as dirty, and we periodically check if the UI needs to be updated. And the UI update is as simple as updating something we call element descriptors. Element descriptors are they are a structure with basically the same fields as toolbar element protocol, but you can think of them as snapshot of state of the toolbar element at this given point. So if any toolbar element changed, we update element descriptors, and because that property is published, it gets immediately picked up by SwiftUI. So if in one frame of UI updates, multiple elements update, it will result in only one element descriptors recalculation, because the element descriptors recalculation is actually triggered by CA display link, which fires only once a frame of UI, and even once per frame. Yeah, and if nothing changed, nothing's recalculated, and nothing's recalculated, UI doesn't get updated. One more problem we faced was actually around popovers. Our toolbar is pretty heavy on popovers. Basically, almost every element you tap, you can tap it for the second time to reveal a popover with additional settings. So if you tap a color, it will allow you to change that color and so on. And all of those popovers were implemented in the old toolbar too. They are just plain UIKit popovers. But as I mentioned, our toolbar is implemented in SwiftUI. So how to marry SwiftUI with UIKit popovers. And because when you present a popover, you need an anchor. You need a view to anchor the popover to. So one option was to probably rewrite all those popovers in SwiftUI, but we also actually didn't want the toolbar itself knowing that it displays some popovers. The toolbar was supposed to be just displaying those toolbar elements, and the rest we wanted to be offloaded to other parts of the code base. So what we came up with is, and you probably noticed it before, is that on each tap, toolbar element gets something called a context. And a context is it's a struct which mainly contains a view. So every UI in the toolbar, every toolbar element every toolbar element underneath, even though it's in SwiftUI, is backed by a UI view wrapped in a UI view representable. And that UI view detects touches. So it has gesture recognizers. It has gesture recognizer, and when it's tapped, and that's a simplified version of it. When it gets tapped, it just passes itself to that context, and later we can use that view to anchor the popover to. This, however, posed another problem, which I need to go back to this list. So when UI view representable gets created, or during its life cycle, you do not have any guarantee that its underlying UI view won't get recreated. So we don't know when SwiftUI calls make UI view method. We don't know when SwiftUI calls this. Most of the time, it calls it only once, so that view is stable. But from time to time, it would call it again and recreate that view, which normally doesn't pose a problem. But when this happens during popover presentation, suddenly our anchor gets lost, and the popover loses an anchor. So this breaks a popover. So what we had to do was basically start caching those underlying UI views. And that's why we have IDs everywhere. Each toolbar element has its separate ID. We make sure that those IDs are unique because they are used both here, but also for ensuring identity in SwiftUI view implementations and so on. This cache is a simple, underneath it's just a simple dictionary where a key is an ID and the value is a UI view, and if it doesn't have a value, it just creates a new view. And this solved our problems with popovers. We basically didn't have to change anything to reuse those UIKit popovers, besides just passing those views we get from toolbar elements. Because in the previous toolbar, we could just reference any view in the toolbar because it was a UIKit view, so you could reference views directly. And that's basically the gist of our toolbar, and I'm hoping to answer some of your questions about it.
Thank you so much for the presentation, Sebastian. I wonder if any one of you has any questions.
Or maybe there is anyone who uses Goodnotes and has some opinions on the toolbar.
That's the best way to share the feedback. Yes. Right? If we actually have no questions, then I have a question. I'm wondering about how do you actually free the views from the cache? Do they even ever get destroyed?
In the cache for each toolbar has its own cache. So main toolbar has its own cache, and we can afford keeping those couple views in a cache for a longer time. So we do not evict them from cache unless they, for some reason, change the type, because the actual implementation is a bit more complicated. But for the floating toolbars, every time the floating toolbar changes, so the tool changes, the one floating toolbar disappears, the next one appears, it gets a new cache. Because the cache is owned by the view controller or the view controller of the floating toolbar. So once it disappears, the cache disappears too.
All right, thank you so much. Any other questions? All right.
Hi, Sebastian.
Hi.
It was a brilliant presentation, actually, in terms of the toolbars and everything. So while I was actually listening to you, so one intuitive thought actually popped up in my mind. Wouldn't you consider having the toolbar in a circular form where it opens as a pie menu? So like, maybe you have seen this, maybe I couldn't explain it better. So it's a circle one.
We actually have that.
And it pops up like when you click center one and then corresponding all presets or other sub-menus can open?
I won't be able to show it right now on the simulator, but we actually have something we call palette. It's supported on iPads with Apple Pencil Pro. So when you squeeze an Apple Pencil Pro, the circular version of a toolbar appears around the spot where you are currently hovering the pencil at. Yeah. So it allows you to quickly change settings. But that's Apple Pencil Pro exclusive feature.
And actually, by you implementing that menu or that feature, I think you can save much of space at the top when you have so many different tools or
yes,
sub-tools.
That's true. However, like we always want to have the toolbar visible, because first, not every user uses Apple Pencil Pro, because not every iPad also supports it. Plus, our app is also available on iPads and macOS. But also, the way we designed that palette is that it only contains the most essential actions. So if you want to do more, or the actions which are not so often used, you can refer back to the toolbar.
Perfect. Thank you. Thank you very much.
Awesome. Thank you for your question. Do we have any more questions? Yep.
Yeah, it's not about the toolbar, but I saw that you are still using letSwift. So do you consider moving to Combine in the nearest future?
Through the code base, we use a couple different approaches. To be honest, the letSwift here was used mostly because of, let's say, backwards compatibility with the existing code base. We couldn't afford at the time to rewrite that part of the app, because actually for about half a year or even more, no, almost a year, we supported two toolbars at once. So we had the old toolbar and a new toolbar living in the code base, both using the same data sources. So yeah, we had to take that, what we were given, basically.
Thanks. Thanks, that's enough.
Thank you. Any more questions?
We have one on the stream.
Oh, nice.
It's in Polish, but I will try to translate in a shorter form. There's a lot of customization in the app. So what about accessibility? Is it supported?
So every toolbar element has, we have a built-in support for accessibility. Every toolbar element has its accessibility label, so it can be read by the screen reader. Also on macOS and iPad OS with Apple Pencil Pro, where the hover is supported, we display hints. So if you hover over a tool, it will show you what that tool is. So you can consider that part of an accessibility tool.
Okay, thank you.
All right. Any more questions from the room? If not, then thank you again for the presentation.
Great. Thank you very much.
And now it's the time for 10 minutes break. Actually, during the break, we'll display a slideshow of pretty much most of the old events from the period of 10 years. Pay close attention to the slideshow because you might actually be able to find yourself on some photos. And feel free to grab yourself a couple of beers or tasty apple juice. And we actually have a few books to give away. So on the same tables that the beers are, you can actually grab yourself a book for free if you would like to get it. Yep, so now for the break. Thank you.
1, 2, yes. Okay, welcome back after a short break. We have the next speaker. And the next speaker is Tymoteusz Pasieka. He will talk about native iOS in a world of game engines, building a children's app without Unity. Tymoteusz is an iOS developer at XTB and co-founder of Smart Kiddo, an educational app for children aged from 3 to 8, built together with his wife. Passionate about AI and its potential in mobile apps, he also plays tennis in his free time. Let's give Tymoteusz a warm welcome. The stage is yours.
Jeszcze nie? Okej. Czekajcie, bo tu jest skomplikowany setup. Oh, sorry, I forgot that this is in English. And to be honest, I agreed to be a speaker before I find out that this will be 100% English. So sorry, apologize for my English up front. I will do my best. Do you see, guys? Okay. And we need a voice sound. And one last thing for the future. Oh, it's not detecting my... Sorry. Yeah, it's always with demo. Let's do this one more time. Not me. Okay. Yeah, we are here, so it's prepared, thanks. And the last one, yeah, voice we will have for the future. Yeah, but let's start from something else. I just want to be prepared. Yeah, like the host said, today I will be speaking about children's apps and how I try to build it without any Unity game engines, cross-platforms, which is not so obvious in this sector of the App Store. First of all, I want to ask if anybody here had ever opportunity to build something for kids in the age of 3, 4, 5. No, yeah, that's what I thought. It's not very common. It's a niche, so we wanted to touch this niche. The app got some good achievements already. We have very high rating in the App Store, about 4.7 with 200, almost 300 right now ratings. We were also featured by Apple in the Apps Wheel of Section in 32 countries for about a month. We got some good downloads numbers and some good engagement in the app, all without spending $1 on it. Yeah, but how all this started? Like I said, I built this with my wife because we were looking for some nice apps in the App Store for kids, for our daughter that was 4 years old that time. And to be honest, I don't blame developers, of course, because it's their job to make money, but most of the apps were not what we were looking for. The overstimulation, the addictive patterns were almost everywhere, so kids can't stop using the iPad, and also their learning patterns wasn't like we thought it would be. The kids were learning not to think, but to repeat some patterns, and there was no reasoning at all. That's why I thought that maybe let's try to build our own app. And here comes Smart Kiddo. Our main idea was to see the hand-drawn walls where every illustration is not a stock or the AI generation, what is very common in this industry. We wanted calm animations that don't overstimulate, but sparkle some curiosity into the kids. And there is an educational journey that tries to teach kids how to reason, how to think, and how to solve problems, because this is at this age the most important thing to learn this kind of stuff. I will do a quick demo so you guys see what the app is about. I hope we will see the sound. So yeah, this is those. Oh, you don't see that. Sorry. We need to switch. Okay. Yeah, is it looking good? Okay. This is the main board of the app, where, like I said, we try to spark the curiosity into the kids. All of the stuff are hand-drawn by the professional illustrator. We are having some slight effects like parallax while scrolling. Some of the elements are randomly animating during the exploration of the kids. I don't know if this is not too big, maybe for me when I'm looking here. We have right now 5 boards, so kids are solving the puzzles, learning stuff about the boards through exploration, which is, I think, the best way for young kids. What is more, when you tap some elements on the board are themed, so every board has a specific topic around it. You can listen to the interesting facts about this.
Elephants are the largest land animals on Earth. They're known for their long trunks, which they use. Blue morpho butterflies are considered to be some of the most beautiful butterflies in the world. The wings are blue on the underside and brown on the dorsal side. So when morpho butterflies fly, the contrasting surfaces of their wings create the illusion
interesting
of appearing
facts
and
for the
disappearing.
kids. Yeah, let's show also, because we will talk later about implementation, all of that stuff in the native way. But I will show also some of the puzzle engines. So this is the curiosity exploring by tapping, but we have also the journey, educational journey, also connected with the teams, where kids are solving simple puzzles by interacting with it.
Which animals can fly?
We have about 9 types of puzzles right now. Each puzzle is to solve some different stuff in the kids' development. And like I said, we didn't want to teach kids repetition. That's why when you run every puzzle, every time, even if you repeat it, it switched the elements. So every time kids needs to think what to move where, not by like repeating that the elephant needs to go to the left, because it will be no point at all. Okay, this is the main features. We have also the feature
on a line. Who is it?
To point the animals by the question that is asked, but this is like a minor thing. And let's go to the details of the implementation. Okay. Like I said, we tried to use our skills. That's why I thought that let's try to build it without any engine, just using simple UI kits with UI and stuff that I know best. There are 3 pillars. There are static elements for the boards that you saw. They are tappable. There are some simple calm animation, and there is this puzzle engine based on the CA layer. The first challenge that I got is how to animate this kind of elements on the screen. There is several ways of doing that in the native iOS. I stress tested each of them. Any of them are also perfect solutions, unfortunately, but I needed to choose something. I wonder, guys and ladies, if you can guess what I have used here for that. What would you use to show this kind of boards with the animations? Would it maybe you can raise hands? Would it be Lottie? Anyone call for Lottie? No. Sprite Kit? Okay. GIF? Yeah, so I suppose that everyone will raise their hands for the last one. Yeah, this is, I think, the simplest solution. First of all, I tried with Lottie, but it wasn't working like I supposed. UI/View animations images also have drawbacks because we have frame-by-frame animations, and there are a lot of images loaded up front into the memory. But what is the limitation? What was initial the limitation? I mean that we can just show only a couple of animation was the advantage because we wanted to not overstimulate kids. That's why on the board we have about 15 animations. The frames are also, the FPS are also very low, so we don't load a lot of in the memory, but it suits good to the board and to the app because it's the simple approach. There are a couple of types of the animations that I made. Most of them are like played frame by frame, but when I add some transitions to it, it can create another effect. So, for instance, we have a balloons that are flying to the top, and there is a frame-by-frame simple animation with just 4 frames of balloons moving, and also the transition that it is flying away off the screen. And we have several this kind of stuff here, and each of this animation was built on the base of the UI image view by me. Sorry, I need a little bit water. And just come to you. Water. I thought I grabbed one, but I think it's missing. Maybe someone can give me a hand, thanks. Oh, sorry. Yeah, everything in the Sparkito is also JSON-based. So all of the stuff that you see on the screen on the board have their coordinates and is configured to the JSON. The same with animation. Every animation has its model with the duration type and the repeat count. Also FPS, everything can be configured to that, so we can switch it very easily later. What was also the limitation of the animation view? Animation images was the expenses when you load all of these images. That's why we are catching them and releasing from the memory when they are not needed. All of that to not blow the app and cause the crash when there is too many of them at the same time. Also, we are not playing them together. They are playing randomly in special intervals. So it's still calm, and we met that criteria of no overstimulating kids. Okay, here is also a very simple effect that you saw on the board. It's a parallax, and it's just a scroll view connected, the translation and the offset of the scroll view connected with some specific layers that are marked in the model that they need to respond to the parallax, and this parallax has also some settings of the ratio that can move some elements faster or slower with the scroll. Okay, we have covered the boards, the static elements, and the animations, but let's now move to the puzzle engine. Here, I have chosen to build everything on the CA layer. It's much simpler than putting UI views on the screen. It has pure rendering. Of course, we need to do manual hit testing and some frame controls, but it's smooth. And also, we have this automatic animation when we change the frame to the core animation, so I don't need to animate anything manually when Kit, for instance, drag a layer to the wrong direction and release it nicely slapped to the initial point by the auto core animation. Puzzles have different types. We can order, select, pair, shapes, but I won't cover all of those types. But what everything this have in common, like I said, it's the puzzle screen is configured is consisting from three stuff. There are static images that you can't interact with on the puzzle. There are action images that you can drag and do specific actions with. And there are shape images that, sorry, it's not images, but objects that are like kind of containers to detect when you drag something into it and if this should snap or make the puzzle solved. So everything is configured to the model and putting as a layer on the puzzle, on the screen. Oh, I got too far. Okay, yeah, but during the demo I showed that I said that every puzzle and everything on the screen has its coordinates upfront configured to the model. And that was a limitation at the beginning. So later I decided to create my own CA layer stack view, something similar to the UIKit stack view. So we can lay out all of the puzzles very dynamically without and randomly. So every puzzle is a different, looks different and make it think every time. I love stack views. I don't know, guys, if you also, but before even Swift UI, I layouted all of my views on the stack views. I had these builders to build it very quickly, very similar what Apple decided to do recently in Swift UI approach. So stack views are great. It was missing for the CA layer, so I built one for me. Yeah, I was also talking about the limitations when building Kit's app. A 4-year-old don't have this motor skills developed so much that we adults. That's why we need to ensure that every interaction with the screen is not a frustration. And every time, even if we have small elements on the screen, on the puzzles, we ensure that this hit area is much bigger than the image itself. That's why we are increasing it during the hit testing for the puzzles. With the minimum tab area, we decided is the best for this age, for kids this age. Okay, I covered the main features, but we recently, maybe not recently, but about a year ago, have added something new to the app. And like I said, we were always having kids in mind. And at the beginning, I wasn't sure if this is the feature that it's safe for kids, especially as such a young kids, to interact with the AI. But I tried. First of all, we released it for a small audience only, but it got some good reviews, and also I think we really made it so private and safe for kids that even Apple wasn't complaining and picky when accepting this one. I will show you quickly this feature because it wasn't shown yet, and later we will talk about it. Sorry for my mess on the screen. Let's run. So every board, on every board we have this static elements of the UI. Here we have this character. Oh, I haven't talked about that. We have also this feature that when kids are changing their characters, what is changing also? We are changing the icon of the app, so kids can find it really better in an easier way. But let's try this AI educator.
Hi, ask me any question about the
Sorry, I prefer asking about Jungle because it was tested before the meeting.
Hi, ask me any question about the jungle.
What does tiger eat? What does tiger eat? It's not Siri.
Tigers
I'm
are
just
carnivores,
pretending to be
which
Siri.
means they only eat meat. They mainly eat large mammals like deer, wild boar, and buffalo. Sometimes they also eat smaller animals like birds and fish. Tigers are very strong hunters and use their powerful bodies and sharp claws to catch and eat their prey.
Okay, yeah. It worked, so it's fine. Actually, it worked very frequently, and I will show you why. Even if the kids are asking those questions. Let's play this presentation one more time. Okay, so the first and I think the biggest challenge is to understand a 5-year-old. I don't know if you ever speak to 5-year-old, but they are mumbling, they are misspelling words, and this is really a nightmare. And when I was testing this with my kids, very frequently the question was completely not about what they want to ask, and this Apple speech recognition wasn't able to recognize it. That's why I created this couple-stage pipeline of speech detection that it's not only using the Apple framework, but also AI. How does it work? First of all, we know what scope of the question will be, because we allow kids to only ask a question about the board topic. So when we are on the jungle, we only can ask questions about jungle, animals connected to a jungle, and such things. So we can predict upfront what kind of vocabulary the kid can use. And we can inject that into the speech recognition engine. So when Apple framework tries to decide and recognize the speech, it can use this domain-specific words to help ASR to understand. That was the first thing, but it still had a problem. So after that, we are trying to send this speech recognition to the AI to decide if this sentence questions make sense, if this is connected to board or not, and based on that, we decide what to go next with. I wasn't also talking about privacy, because you may think, yeah, this feature is very easy. Just use some kind of AI conversational agents. There are a lot of them already, and it will also answer all of the questions, and maybe it will work even better. But Apple won't allow to do that. Also, if you read 11 Labs privacy stuff, there is written that it can't be used with the kids, because we need to protect that the voice is not going out of the device and be processed somewhere else. That's why with speech recognition for the Apple, we can require on-device recognition. And with this setup, we ensure that no voice are going at all out of the device to the cloud. But even if it goes, to be honest, Apple protects it well, and it's allowed to use with the children, because it doesn't support all of the languages right now, unfortunately. But we all waiting for the Siri about 15 years, so we can wait another one. Okay. yeah, that's what I was talking about. So we have some settings for the speech recognition. We can require on-device recognition, add some punctuation, and also inject this vocabulary that is specific for the board to make this recognition better. And after we recognize the speech, we have the system prompt to determine if this is about a topic. If not, we need to stop because we don't want to answer about anything else. It might be safe. We need to create the content that it's going to the kid after all. That's why when we are using AI, of for instance OpenAI, we need to decode the strings of unclear wrong to later use it in the models. Let me see. Yeah, that's what I thought. That's what I said. So when we understand the question, we try to process that, and we are returning if this is related to if not related or unclear. And then, of course, there is a specific sound playing to the kids that he needs to repeat or change the subject of the question. Also, after releasing on-device foundation models by Apple, and when I was watching WWDC and they announced that there will be such feature, I was delighted because I had already this function built, but using of course, some outside providers like OpenAI. And yeah, I said, let's try it. And even before it comes to even before iOS 26 was released, I already had this implemented and was ready for the releasing of the newest feature. What it gives me, the foundation models, it gives me 100% privacy because everything, even the AI generation, is going on the device. What else? We have 100% offline support, so this feature can work completely without internet, thanks to Apple Intelligence, of course. What else? We have macros that makes the decoding and processing and working with this much simpler. That what OpenAI needs to return me as a string of wrong unclear. Here I have the simple accuracy enum that makes all of that much simpler. But what's going next? If we decided that the question is about the topic, we need to generate this answer. So this is also the prompt that has several safety rules. So we are sure that the question is appropriate for the kid, and we are not going off topic, of course, and saying something that parents can be pissed off about to hear. Yeah, Apple Intelligence right now is preferred on the Smart Kiddo. Unfortunately, together with the Siri stuff, it's not for the Polish language, so it's working with English very well. But when when it fails, we have the fallback to OpenAI, and later we are trying to say it aloud to the kid after generating the answer. What we use for that? We have 11 labs connected. All of the sounds in the app are generated to 11 labs. So when the AI generates the answer, we are sending it to an 11 labs to speak it aloud. But to make it 100% offline, and kids this age can read, so everything needs to have voice response. We have offline fallback for the Apple AV speech synthesizer. Of course, it's not sounding the same as 11 Labs, but still good. And you can, I don't know if you work with this framework, but you can choose some kind of voices, like premium voices here, and even ask the user to download these premium voices for the synthesizer, so it works much better. Okay, yeah, this is also some kind of code of text-to-speech manager. We have two types of manager. This is how we connect with 11 Labs to generate the audio and play. So basically, we just connect. We just send the text, choose the voice, and saving the file to play later. Here is the complete pipeline. After also, maybe let's summarize this. The child speaks. We try to recognize what this is about by vocabulary injection. Later, we are sending this to AI to determine if this is related to the topic and if we can process later to generate the answer. If the answer is generated, we limit to 400 characters. We send it to some kind of text-to-speech manager based on the internet connection to generate answer. What is more, I also wanted to not to give the parent decision if they want their kid to even use this feature. That's why during the onboarding we are asking the parents if they want to, if the kid can interact with this feature alone or only on their supervision. We also have some limitations for the daily questions. For the free app, it's 1 day, and for the premium, we have 10. Okay, it wasn't easy, yeah, but I got to the end. Here's the quick summary, and also if you have kids, I really will be glad if you download the app and try it. I think the kids and also you will like it because it's not ending with the cry when you try to take the tablets off, like in other overstimulating apps. And we always building new features have our kids in mind, so we are trying to do the best, not focusing only on the revenue and engagement, retention, but also what is really good for the kids. Yeah, I think I finished. If anyone have any questions.
We have a first question here.
Yes, thank you for the great presentation. I really love the UI. The app's so beautiful, and I have a question about the boards. If you do you have some DSL for creating those boards? So let's say you add a new board, let's say Antarctica, and
yeah.
Do you have to build it from scratch, or do you have some language which you can quickly describe it, quickly build it?
You know, first of all, we need to send it to Illustrator because everything is hand-drawn. So we start from the conception. We are trying to create the conception of the board, sending to the Illustrator. Illustrator is generating us Photoshop images. And thanks to AI, we can create a simple script that can map those PSD file into the JSON that we are using into the map. So the rest is very simple, like to inject that. And all of that, I have built several skills using AI that helping us create those JSONs for puzzles, for boards, for animations. So everything is semi-automated right now when creating new boards. Of course, we need very high initial input from the Illustrator, graphic, and some content, yeah.
Yeah, but then later that app somehow parses that JSON and builds those CA layers, image views, and so on. It's not like you have to lay out them by hand, or...
No.
Okay.
On the JSON, every single element has its coordinates on the screen, and later we have this parser of JSON that is mapping it to the data models, and later those data models are used inside the app to generate the view of the board.
Perfect. Thank you very much.
Okay, there's another question.
Great presentation, thank you very much. And yeah, I will have one question regarding the 11 Labs text-to-speech. Are you connecting to the 11 Labs API directly from the app or through some kind of backend?
No, I'm connecting directly from the app to the 11 Labs using API keys. API keys are secrets in the CI, because all of that we have connected to the Xcode cloud. So the secrets are passed to the app later to use when doing the connection.
All right, thank you.
Thanks. Do we have any other question? Okay.
Thank you. Hi, Timo. It's a very good concept, like when parents come with the concept, like we should do something for the kids, and to come up with a very simple idea. Coming back to the 11 Labs, actually, I love this tech as well. My question is, you being a developer, how was your developer experience when you were integrating the 11 Labs in the app? And maybe you already have something for future, like you want to go in the advanced stages with the languages, with multiple languages maybe, or something. Maybe you can have some character who is speaking in the different language using 11 Labs. So just from a developer perspective, how do you see or what developers should be taken care of when they are implementing the 11 Labs?
Yeah, we actually support a couple of languages right now, because we have Polish, English, and Deutsch, and we are using. We chose one voice about 2 years ago, and to be honest, we haven't changed that. But I think we can find a better voice right now. And yeah, we have some plans of building the new boards that will have some kind of voice clones of the people that you may know, together with those people. And yeah, we are trying to use what 11 Labs is creating, because I really love how it is going. It's the biggest company right now from Poland, and I really delighted to use it in my project also.
But have you experienced any challenges from 11 Labs in terms of?
No.
I'm asking because like. They are very fast forward now in terms of developer experience. So it's a very good example. Like, unfortunately, you were using 11 Labs. So just wanted to have your experience and your viewpoint, like how they can make it more better when it comes to the developers.
From my perspective, everything is great. Connecting this AI feature to 11 Labs is like 5 minutes of work. So yeah, from my perspective, is really simple. The other audio files we generate up front, so they are. Some of them are attached with the bundle. The rest are fetched from the cloud after app download. Yeah, but those were generating through the simple scripts that we built, and it's also very easy. We have just Excels and the bash script that is taking this Excel, sending to the 11 Labs, and downloading those files that we can later inject into the app. So it's also very easy. And I think it's even getting better. So I'm talking about my experience for like half a year ago, and you know it's moving very fast.
Perfect. Thank you. Best of luck.
Thanks. Do we have any other questions?
I might actually have one.
Oh, you have microphone.
Yeah,
I do have a microphone. Yeah, thank
Okay,
you.
great.
So thank you for the presentation. I really love seeing that you went above and beyond to provide safety for children. If I had children, I would totally trust you with them. Yeah, so my question is actually not about children, but about the animation format, because that was quite interesting. I wonder if you have ever tried animated PNGs or APNGs, because this is not something that is natively supported by UI image view, but I had a pretty similar domain problem to solve, and it apparently turns out that the CA layer natively supports animated PNGs, and I saved a lot of space in the app bundle by using animated PNGs, because the whole package gets compressed as a single file. So if you, I'm wondering if you have heard about it, and if yes, if you have actually tried it.
Yeah. To be honest, this is, I think, the part of the app that still can be optimized, in my opinion. And good to hear about this, because I haven't heard about animated PNGs, to be honest. Yeah, and I will definitely try it after all. Yeah, but I don't know if this will let me to decide, because we have these frames, and sometimes I play from frame 1 to 5, sometimes backwards, sometimes I flip, sometimes I combine with something else, and I don't know if this PNG, animated PNGs also had this.
Yeah, you have a perfect frame-by-frame control embedded in CA layer. So if you're looking for a place to optimize the size of the app, that would be the first thing I would look for.
Yeah, I think the factoring is coming up for me, so thanks for saying that. Yeah, I will definitely try it, because the memory pressure is quite high. We don't hear complaints, but me as a developer, I see that there is a place to improve. So.
All right, thank you. So kudos to you and to your wife, because the artwork is really pretty. So give her a hug.
Okay, yeah. She may watch us, so yeah, let's see.
Yeah, greetings.
Maybe we'll hear that.
Awesome, thank you.
Thank you. Do we have any other questions? I can see. I have no glasses. But I think that's all the questions for now. So thank you, Tymoteusz. Big applause for Tymoteusz.
Yeah, thank you for inviting me. I will grab my stuff.
Almost.
Do you need a hand? Oh, it's tight in here. Yep, there we go. Hopefully. All right, so our anniversary 10-year 35th edition of letSwift is coming to an end. So thank you for coming. And before we actually finish and say goodbye, please don't forget to follow us on the X platform. You can find us at letSwift Raw handle. And right after the event, we will share the feedback form with you. So if you have any feedback about the event, please feel free to fill our survey. And you can actually find all the links, all the QR codes that we have shared today on the survey. So we heavily encourage to take a look. Yeah, and we want to keep improving for you, so we really value your feedback.
Yeah, so after the event, we go to the after party, which will be held as usual in Szklarnia Pub. So you're all invited, and we will see you there. And as the last words, we want to thank you for coming for letSwift and supporting the letSwift. We want to thank every one of you which is helping us to organize, Karolina, Veronika, and the Barbara team. So thank you, and yeah, see you on the next event. So thank you.
Thanks.
And now it's time for a selfie. So come to the stage, please.